Right now, somewhere over Europe, a giant invisible lid of hot air is sitting on top of the continent, and it is not where scientists expected it to be, and that single fact is making this entire situation far more dangerous than anyone originally predicted. If you think a heat wave is just a few uncomfortable days of sweating through your shirt, this video is going to completely change how you think about extreme heat, because what is happening across Europe right now is not a normal summer. It is a repeating pattern that keeps breaking records in places that historically never had to worry about this kind of danger. Let's start with the basics, because understanding why this is so alarming means understanding what a heat dome actually is. A heat dome forms when a massive area of high pressure builds up in the upper atmosphere and essentially gets stuck in place. Instead of moving through like normal weather systems do, this dome of high pressure parks itself over a region and traps hot air underneath it, almost like putting a lid on a pot and letting the heat build with nowhere to escape. As the air sinks inside this dome, it compresses and heats up even further, pushing temperatures higher and higher. With each passing day, the system remains locked in place. Meteorologists describe this pattern using a term called an omega block, named because the shape of the jet stream during these events resembles the Greek letter omega, with a high pressure ridge sitting directly between two low pressure systems on either side. Here is where this year's situation becomes genuinely unusual, and honestly a little unsettling for climate scientists. Heat domes over Europe have traditionally centered most intensely over the Iberian Peninsula, meaning Spain and Portugal, the regions closest to the Sahara Desert where superheated air masses originate. That is still happening, and it's still brutal, with temperatures pushing past 45 degrees Celsius in parts of Spain this summer. But what has caught meteorologists off guard is how far this heat dome has that almost never experienced this level of sustained extreme heat. Instead of staying contained to the southwest corner of the continent, the dome has stretched northward and eastward, locking directly over Germany, pushing into Poland, and reaching all the way up into the Baltic region, areas with a completely different climate history and infrastructure that was never built to handle this kind of prolonged thermal stress. Think about what that actually means on the ground. Countries like Germany, Poland, and the Baltic states typically have moderate summers with buildings, transportation systems, and even hospital infrastructure designed around the assumption that extreme heat is a rare exception, not a recurring summer event. When a heat dome locks over a region like Iberia, at least there is decades of adaptation behind it. Buildings with thicker walls, widespread air conditioning, and public health systems that know exactly how to respond. When that same intensity of heat dome parks itself over Central and Northern Europe instead, none of that adaptation exists yet, which means the danger to human health, agriculture, and infrastructure is dramatically higher than the raw temperature numbers alone would suggest. And this hasn't just happened once this year. That's what makes it so alarming. Europe has already been hit by multiple separate heat dome events since late May, one breaking records across Spain, the UK, Germany, France, and Ireland in May, another parking directly over France and Germany in June that was so severe it triggered red alerts for extreme fire danger from Berlin all the way to Prague. And now a fourth major heat dome building through late July into August, once again centering over Iberia and France, but threatening to expand across the rest of the continent, just like the previous events did. Scientists studying this pattern have called the June event the region's most severe heat wave ever recorded, with a formal scientific analysis concluding that this level of extreme heat would have been virtually impossible just a few decades ago without human-driven climate change. And researchers stated plainly that the climate crisis is unequivocally to blame for what is happening. Now, let's talk about why this particular kind of danger is so much more severe than people realize. Because the daytime temperature numbers you see on the news are honestly not even the scariest part of this story. The real killer hiding inside these heat domes is nighttime heat. Under normal circumstances, temperatures drop significantly after sunset, giving the human body crucial hours to cool down, recover, and repair itself from a day of heat stress. But during a locked-in heat dome, especially one trapped under high humidity, nighttime temperatures can stay dangerously elevated for days or even weeks in a row, denying the body any real chance to recover. Scientists studying this year's events found that Europe's sweltering nighttime heat is now roughly 100 times more likely than it was back in 2003. The year of a catastrophic European heat wave that ended up killing more than 70,000 people across the continent. That comparison alone should tell you exactly how seriously researchers are taking this pattern. The human cost is already climbing this summer, and it's not just heat exhaustion showing up in emergency rooms. During the June heat dome event alone, French officials confirmed at least 40 people drowned while trying to seek relief from the extreme heat in rivers, lakes, and coastal waters. A devastating reminder that even the ways people try to escape dangerous heat can turn deadly. Elderly people, young children, outdoor workers like farmers and construction crews, and anyone living in poorly ventilated housing built from heat-trapping materials like concrete face dramatically elevated risk during these prolonged events. Heat exhaustion, if it goes untreated, can rapidly progress into heat stroke, a genuine medical emergency, where the body's core temperature rises so high it begins damaging vital organs. And every additional day, a heat dome remains locked in place compounds that danger further. Beyond the direct health risks, these shifting, expanding heat domes are creating a secondary crisis that gets far less attention: extreme wildfire danger. As soil that is already exceptionally dry from repeated heat waves gets baked further by yet another locked-in high-pressure system, evapotranspiration accelerates dramatically, meaning plants and vegetation lose moisture at an unusually fast rate. Combined with low humidity and erratic, gusty winds that often accompany these systems, the conditions become almost perfect for uncontrollable wildfire ignition and rapid spread. National weather services across Central Europe have already issued red alerts specifically citing extreme fire danger, warning that even a small spark under these conditions could explode into a large-scale wildfire within hours. So why does this keep happening? And why does it keep happening in places scientists didn't originally expect? The honest answer researchers are converging on involves changes to the jet stream, the fast-moving river of air high in the atmosphere that normally steers weather systems across the globe in a relatively predictable pattern. As the planet warms, particularly as the Arctic warms faster than the rest of the globe, the temperature difference that drives the jet stream's strength and shape is shrinking. A weaker, wavier jet stream is far more prone to getting stuck, allowing high-pressure ridges like these heat domes to lock into place for would have, and to build in locations further north and east than the traditional European heat waves. If this kind of climate science genuinely matters to you, make sure you like this video and subscribe, because we break down these extreme weather patterns as they develop before the headlines catch up. There's another layer to this crisis that rarely makes the headlines, and it's the strain these repeated heat domes are putting on Europe's power grids and water supplies at the exact same time. As temperatures climb into the 40s, air conditioning demand across the continent spikes dramatically, even in countries where home cooling systems were historically rare because summers simply never got hot enough to justify the cost. Power grid operators in Germany, France, and across Central Europe have had to manage sudden surges in electricity demand precisely, during periods when extreme heat is also generation methods, including nuclear plants that sometimes have to reduce output because the river water used for cooling has itself become too warm to safely discharge back into the environment. At the same time, prolonged drought conditions building underneath these locked-in heat domes are draining reservoirs and drying out agricultural land across multiple countries, threatening crop yields for staple foods and driving up water restrictions in cities that rarely needed them before. Agriculture is taking a particularly hard hit this year, and the timing could not be worse. Repeated heat domes arriving in rapid succession since late May have given crops almost no recovery window between extreme heat events. Vineyards across France and Germany, orchards across Spain and Italy, and grain-producing regions across Central and Eastern Europe are all reporting stress from the combination of extreme heat and increasingly depleted soil moisture. When a single heat wave hits, farmers can often manage the damage, but when heat dome after heat dome locks in with barely a break. Between them, the cumulative stress on crops, livestock, and soil compounds in ways that are much harder to recover from, and agricultural economists are already warning that this could translate into higher food prices across the region later this year. Hospitals and emergency medical services are facing their own version of this compounding stress. During a single, short heat wave, emergency rooms typically see a temporary spike in heat-related admissions that returns to normal once temperatures drop. But this, and again, sometimes with only days of relief between events, is preventing that normal recovery period from happening. Emergency departments across France, Germany, and Spain have reported unusually sustained pressure on their systems throughout the summer. Rather than the short, sharp spikes hospitals are typically staffed and prepared to handle. Elderly patients in particular, many of whom live alone, are at heightened risk during these repeated events because the body's ability to regulate temperature naturally declines with age, and prolonged nighttime heat gives them even less opportunity to recover between waves. It's also worth understanding why places like Germany, Poland, and the Baltic region are especially vulnerable when a heat dome does lock in over them, even at temperatures that might seem routine for Southern Europe. Building design across much of Central and Northern Europe has historically prioritized keeping heat enduring long, cold winters, using materials and construction methods that trap warmth rather than release it. That same design becomes a serious liability during extreme summer heat, turning apartments and offices into ovens that struggle to cool down even overnight. Combine that with historically low rates of residential air conditioning in these regions, and you end up with a population that is physically and structurally underprepared for the kind of sustained extreme heat that Southern Europe has spent decades adapting to. What makes this summer's pattern especially significant for the future is what it suggests about what's coming next. Climate researchers studying the jet stream's increasingly erratic behavior warn that as blocking patterns that allow heat domes to lock in place for extended periods are likely to become more frequent, not less, and increasingly capable of forming and intensifying in locations that have never needed this level of preparation before. That means the infrastructure gap currently being exposed across Central and Northern Europe this summer isn't a one-time problem to fix and move past. It's a preview of a new normal that governments, city planners, and public health systems across the entire continent are now scrambling to catch up with. A heat dome locking over Berlin or the Baltic coast with the same intensity once reserved for southern Spain is not a freak coincidence. It is becoming part of a repeating pattern that experts warn will keep intensifying as global temperatures continue rising. The infrastructure, health systems, and emergency planning across huge parts of Europe simply have not caught up to this new reality yet. And that gap between what these regions are prepared for and what they're now actually experiencing is exactly what makes this year's heat domes so much more dangerous than the raw numbers alone would suggest. Keep watching the skies over Europe in the weeks ahead, because if this pattern holds, it likely won't be the last heat dome to show up somewhere nobody expected it. And if you want to stay ahead of the next extreme weather event before it makes headlines, subscribe now so you never miss an update.